Okay, let's do problem number 28 on the 1988 mechanics multiple choice test. And so let's read the problem. It says the radius of the Earth is approximately 6,000 kilometers. The acceleration of an astronaut in a perfectly circular orbit 3,000 kilometers above the Earth would be most nearly one of these. So I'm just going to draw a quick sketch of this. So here's the Earth. So from here to here, it's about 6,000 kilometers. So, let's see. So 1, 2, 3, 4, 5, 6. So each one of these spaces represents 1,000 kilometers. Now, in this problem, we're only 300 kilometers above the Earth's surface. So you'd be about right here. I mean, it's almost the air. You would be right about here, just barely above. Relatively speaking, you're really not very high above the Earth's surface. So now we know that the acceleration of gravity, if you're at the Earth's surface, is 9.8 meters per second squared. So we're barely above it, so it's just going to be a little bit less. Now, it's not, and by the way, see A, B, C, D, and E. Let's eliminate some answers. I know it's not 0. Now, it might fool you because people think, oh, you're in orbit, you have 0 gravity. But you don't have 0 acceleration. I mean, you are in free fall, you have a centripetal acceleration. So A is not correct. Now, it's 9.8 meters per second squared. It's not going to be greater than 9.8. So E is totally ridiculous. B isn't much better than A. So really it's between C and D. But look at it. You're barely above the surface, so it's barely going to be less. So here it's about half. Well, to have half the gravity, you would have to be a significant fraction of the radius above. If you're a whole radius above, it would be 1/4. But somewhere in there it would be about half, but not, not this close. So therefore, just by a process of elimination, the answer is D. You're barely, relative to the Earth's radius, you're 300 kilometers is barely above the Earth's surface, so it's just a little bit less than 9.8 meters per second squared. Does that make sense? Okay, that is all.